All right, so this is my first time presenting, so if you guys don't know me, my name is CJ May. I go by LawnDoc on Slack and Discord. I'm a senior IT security analyst at Vermeer Corporation, which is in Pella. We're a manufacturing company. That's just a little bit about me. So the talk today that I'm talking about is seccomp filters for containers, and it's kind of a funny story. Jake and I found out yesterday that each other were talking about seccomp. We didn't know that we were both giving related talks, but it actually ended up working out really well, and that's the reason that we flipped our spots, is because Jake kind of gave an introduction into seccomp and kind of what it is, and my talk is a little more about how it can be applied, especially in more of a business kind of situation where you don't want a ton of overhead and you don't want to, need somebody with a lot of expertise in syscalls and low-level operating system internals. So my talk is on how to automate the creation of application-specific seccomp filters. So like Jake said, seccomp is basically a way to restrict the syscalls that can be made by a program. So you can, in theory, limit a process to being able to do only exactly what it needs to do. So if it gets exploited and maybe an attacker is trying to spawn processes from it, you can block that syscall as if it isn't needed. So seccomp works with all major container runtimes, and there's even support for it in orchestration tools like Kubernetes. And so it kind of begs the question why it isn't widely used yet. And I think part of the reason is that there's not a ton of resources out there for easily creating seccomp filters without having a deep understanding of syscalls. And so that's kind of what I set out to do here, is to make it a little bit more accessible and a little bit more relevant to current development processes in software engineering. So software engineering, typically things are kind of shifting toward DevOps and containerization, and so that's kind of where I went with mine. And the initial idea that I had was to figure out some way to just capture all the syscalls that a container makes in its life cycle and basically just pump those into a seccomp filter. And I was telling one of my coworkers about it, and they had just read about this tool that people at Red Hat had made that was doing exactly what I was trying to do. So saved me a lot of time, and so let me show you that tool just briefly here. So this is OCI, stands for Open Container Initiative, and OCI basically it sets the standards for how container runtimes should operate and what kind of interfaces they should provide to containers. And one interface that they provide is hooks that can happen before a container spins up, after a container tears down. These are actions that happen that the container runtime takes care of. And so these people at Red Hat, they created a seccomp BPF OCI hook that before a container is spun up, it starts recording all the syscalls that the container makes, and after the container is torn down, it will take all those syscalls that it recorded and it'll pump them right into a JSON file, and that's your seccomp filter. So I'm going to show you a demo of the tool and kind of how that works. Can you guys see the font okay? Let me just, 1 second here. I'm not on my VPN. There we go. Cool. Can you guys see the font okay? I can bring it up, yeah, okay, thanks. Is that better? Can you guys see that okay? Awesome, okay. I just want to make sure everybody can see everything. So you're gonna have to bear with me since I'm doing a demo. I just put everything I needed into files so I wouldn't forget how to put the commands in. So the first one we have to do, so I need a little bit of background here. So since the people at Red Hat developed it, they're not using Docker, they're using their own container runtime implementation, which is Podman. And so Podman it's basically the same syntax as Docker. It's pretty backwards compatible. You can use Docker files to build your containers and stuff like that. It's just think of it as Docker, but it's their tool, and that's how they had set it up. So basically what we're gonna do here, I've already installed Podman. I'm on a Fedora server, since you can see that. And so I've installed Podman, and I installed a package called, I installed their package that I just showed you on GitHub. So what we're gonna do, we're going to run, in a container, we're just gonna run the ls command to list the root directory, and we're gonna pipe that into dev null. I'll just copy that so I don't have to type it all again. So what we're doing, podman run, so we're running the container, and we're annotating it so that it will trace the syscall, and it's going to output the syscall into the temp directory in ls.json. So we're gonna run that. Gotta do this because it's on sudo. Probably didn't type it in right. Oh, okay. So it didn't do anything because I am piping the output into dev null. So that's why it didn't show anything. But if we check, let me do this. If we check the output file that it was supposed to make, this is our setcomp profile. So it ran ls, it captured all the syscalls that were made when the ls command ran, and it piped them right into this JSON file, and they're all listed here. So now what we're gonna do is we're going to run the ls command with that setcomp profile, and we're just going to verify that ls can still run with all the syscalls that we just captured, and it can. And now what we're going to do is we're going to add some extra capability to the container that we didn't do when we recorded the setcomp profile. So now we're doing some additional things that, you know, potentially are needing additional syscalls that aren't recorded in our setcomp profile. So all I did was I added the -l flag. And now you can see even adding the -l flag, it's using additional syscalls, and the container isn't allowing that because we're using that setcomp profile that is restricted only to the syscalls that the regular ls command needs. Step 3. And so another feature of this tool is that it allows you to take a profile that you're already using, and you can update it with additional syscalls. And so now what we're doing, we're going to be in recording mode again rather than blocking mode. And we're taking the input file, which is what we had created before, and we're just starting with that so we don't have to start from scratch. And then our output file is going to be lsl.json, and we're going to run the command with the -l. And again, we're in monitor mode here. So we created the new one, and now we can go back and run this again with ls-l, and we're going to use our new setcomp profile. Such file or directory. Classic demo, something's gonna not work right. But that's a capability that this tool can do as well. I'm not gonna get into too much troubleshooting right now just for the sake of time. So that's the seccomp kind of generation tool that I'm gonna be using for the rest of my slideshow here. So it's a really cool tool, but how do we make that useful and efficient in a professional software development environment? So the challenges that come with a professional environment is we don't want a lot of overhead. We don't want to have somebody like me just sitting and running podman commands just to get a seccomp filter for each of our applications and every update that happens when we add new features. We want that all to be automated without human intervention. So we use CI workflows, which is just part of a regular DevOps process. A lot of mature software engineering, parts of IT, they all have CI pipelines and automated testing and everything. So the next challenge is how do we make sure that we get all of the functionality whitelisted? If we have a complex container that's more than just running an ls command, there may be 50 API calls. How do we make sure that we're allowing all of the syscalls and getting all that functionality recorded? Well, we can run the seccomp OCI hook that we just used in monitor mode during our unit and functional tests. Part of a mature CI pipeline is having automated unit tests to make sure that all of your code is being tested. And so while we're doing that, we might as well just record all the syscalls that are being made. And then how do we get that filter from the CI pipeline that we just ran all those tests in back to the repo? Well, you can actually just run git in your CI pipeline and just commit it back to the repo. So this is our setup. I have a demo app that I'm going to show you guys. And so the setup is in GitHub, and we're using GitHub Actions as our CI automation. And I'm using a self-hosted Fedora runner, so that server we were just logged into, that's actually where all of the CI automations are running. And there's a reason for that. It's because the GitHub default ones are Ubuntu, and technically you can set all this up in Ubuntu. You can just compile from source, but it adds time and complexity to our CI automation. So I'm just using a self-hosted runner. So what we're going to do, we're running a GitHub action to do everything I just talked about. We're building the container. We're podman running it with the seccomp OCI hook to record all the syscalls. We're running automated tests while that's running, and we're going to commit that back to the repo. So let's check that out. This is my GitHub repo. Currently this is private, but after tonight I'm going to be releasing this so that it's a public repo and you guys can all check it out. So for those of you that aren't familiar with GitHub and how GitHub automation happens by defining your steps in a YAML file. So I'm just going to kind of read through this code here, and I'm going to blow this up so you guys can read that. So the name of my workflow is generate seccomp filter, and I'm ignoring, so basically this workflow is going to run every time that I push new code to my repository. So every time I update my code, this is going to kick off again, and it's going to generate a new seccomp filter, except for when I actually push the seccomp filter from the automation. So we're running it on my Fedora server. So all it does is it checks out my code, pulls it to the server. It makes sure that Podman and the OCI hook are installed. We build the container that contains my app, and then we're going to run the container and trace all the syscalls while it's running. And when we've done that, we're going to start the container with my automated testing script. So in my container, as part of the app, I have a script that kicks off all of the automated testing that happens in my CI pipeline. And so when I run the container, that's just how I kick those tests off. So at this point here, all the automated testing is done, the container is done running, and now I'm going to commit the setcomp filter that was just generated back to my repo. So all I do is I set my username to being, this is a bot, it's being automated, and then it commits the setcomp filter to my Git repo, and it pushes it back to GitHub to the same branch. So in my code here, just to kind of show you what this server is, I wouldn't recommend running this server yourself because it is damn vulnerable. It's got a couple of different API endpoints. We have a dummy function that I just set up to add a little bit of functionality to make it slightly more complex, and it really just is looking for valid input. And we have this other function that some idiot programmer made that just runs any command that you pass into it. And so if you wanted to play around with this yourself, after I make it open source, you can pull down the repo, you can run the container locally on your system, and you can try to exploit the API with the syscall running, or with the setcomp profile applied. And when you're doing that, it should restrict it so that it can't actually do anything other than what the container was tested to do. So backing up, looking big picture here, this whole automated workflow, that YAML file that I showed you, you can apply this to any application. All you have to do is make sure that your test coverage is, hitting all of the functionality of your code, and it'll automatically generate that setcomp profile with an application-specific whitelist filter of syscalls. So if you wanted to do that yourself, I do recommend setting up a self-hosted actions runner or build server, depending on what your CI workflow looks like. And it should probably be running Fedora because Podman and the OCI hook are just in the DNF repositories. You could compile the OCI hook and Podman from source on Ubuntu. It just takes a lot longer. Another thing, you'll want to make sure that your self-hosted runner can run Podman as root without a password because it's being automated, so your automation can't enter a password in the middle of it. So you just add the sudoers entry to make sure that your runner account can run Podman. And this is one more caveat. The reason that my repo is private right now is because GitHub does not allow self-hosted runners on public repositories. That's for security reasons, and you can't override that default unless you are an enterprise organization. So that's just a little heads up on that. If you're going to be testing this yourself, you have to have a private repo to run a self-hosted server. And then the other thing I just want to remind you of is if you're going to be doing this, you need to make sure that you have a very high percentage of your code being tested while the syscalls are being recorded. Because if you're missing some functionality of your code while the syscalls are being recorded, it is probably going to get blocked by setcomp in prod. So you don't want to have to explain that one to your admins and developers. So that's all I've got. Do you guys have any questions on that? So for those of you that may not have heard the question, he was asking how do you figure out if it's setcomp that's blocking something in prod potentially, or in, you know, QA or whatever, whenever you catch that. Typically, it'll be some sort of error about permissions not being granted or you not having enough permissions to do something, because what setcomp is doing is it's restricting the syscalls, and when you try to make a syscall that you're not allowed to make, it's just going to say no, you can't do that, and it'll give you some generic error about permissions not being allowed, and that'll be kind of your tip off that, oh crap, that might be setcomp blocking something that we missed. All right, thanks guys.